Hello, everybody. Welcome to our first little walkthrough for the week tree lecture notes. I'm feeling a little sick this week, so I won't have the camera on, unfortunately. But again, I'll try my best to walk through everything. And apologies if there's any coughing or anything. I'll try to edit it out. But to get started here, the week tree lecture notes is going to go ahead and looking at these concepts of classes and how they represent objects. And this is very important because object-oriented programming, which is a core CS concept that you're going to be learning here at DePaul, is very important for us to kind of understand going forward. So before we actually delve into each of these the notes here, I just wanted to cover the notes here are pretty straightforward with it, but each object is going to have an identity, a state, and a behavior. And essentially, an identity where we can distinguish multiple instances, you can refer to this as kind of like ourselves as humans. Everyone is a human in the class, but some of us might have different names or IDs or identities that differentiate us from each other. Because let's just say that we changed one instance of the age of one of us in the class, we don't want to change that instance of age for everyone. So identity is going to be what distinguishes each type of object that is created. The state of an object is going to be pretty much straightforward as like, okay, what's your hair color? What's your eye color? How do you, what's your hair, eye color, your height, and so forth? And your behavior is going to be what these objects actually do. So like walk might be a behavior, talk, blink, and eat. Those are all behaviors of the object. So again, every object is going to have an identity that separates it, a state, the properties that are associated with it, and then a behavior, which is what we could do with it. Now, we actually look at a few different classes here. The string class, the characters inputting it, and then the character class, and it's referred to as char. You might have heard some people say char or care. If you use Google Translate, it says char, so I'm going to go with char. But again, character or char, what essentially this is one of the primitive types of Java. And I wanted to make a point here. In Python, if we're familiar with it, the four primitive types are a double, float, int, boolean, and string. In Java, it's a little bit different. So in Java, we have a few different primitive types, but the main ones that we'll begin looking at is integer, a long. Long is just a longer long, or long is just like a very large int. And then we're going to be looking at double, boolean, and char. And you'll notice here, we actually don't have a string in one of our primitive types, unlike Java. So a string is actually an array of characters in Java. So that is where it's going to be a bit different. And that's just something small to point out so that when we look at this behavior in a few moments here, we'll see what's actually going on. So again, if we go ahead and just kind of follow what the notes are going for us, straightforward enough, we can create a new string. I'm going to call it str. I'm going to say string, and then some string we made, exclamation point. And then simple enough, we are going to go ahead and just print out this string here. So this is pretty much straightforward. In the notes, you'll notice here, or excuse me, if you download the Java files, there's a compile errors.java file that is purposely not able to run, so just make sure that you note that. And again, we get the sum string we made. Now, what we could do with here is each object that we saw earlier has behaviors and states. So what are the attributes of this, what are some states of the string? Well, we could probably go ahead and get the size of the string or the length of it, and then certain characters about it too. But how do we actually access these states of this string? We have to use some behaviors. So what we can actually do here is if you type out str, you'll notice it will highlight it with the other strings here. And if you put a dot after this, you'll get a bunch of different methods that are the behaviors of that a string can have. And you'll see here, I want to kind of focus on the format of each of these. The way that these work, and if you hover over them, it will actually give you Java is really nice because it gives you a very easy read through of what this actually does. But if you see here, it gives me the method name, car at, and then it says int index. Now, what does this mean? This means that this is the parameter that you put in to try to find the index value of it. And you'll see here we get a colon and then a car. And what this does is it goes ahead and it returns the so this is the return type of this method. So this method is called caret. It's going to take in an integer for its parameter and it will return a character. And then you'll see here it's associated with the dash string tells you what the parent object is. So this is all strings. And you'll notice here because of inheritance and these question mark here, if you see some of these, this just means object. That's just general. It can kind of be anything. It's an optional if you've ever done other programming. So again, though, if you actually read, you don't have to memorize all that information. If you see over here, it will tell you the parameter is an index, the index of the car value, and it will also tell you the return type. So the return type here is the car value at the specified index of the string. So if I actually go ahead and I type in 0 here, and what I'll do is I'll go ahead and actually print it out like so. You'll see here, if I say print, I get an S. And now if I go to the very end, or maybe I'll just go to 6 or something, I get a T. So if we see here 1, 2, oops, 1, 2, 3, 4, 5, 6, and I get, oh, I missed one. 1, 2, 3, 4, 5, 6, and then we get that value there. So again, you can keep increasing this guy here. These are accessing the indexes. And in the notes here, there is a ton of different types of methods that we can use. And it goes into detail about what each of these are. You can use these notes to go ahead and figure out what everything is. And again, we are going to be checking this out with some scanner input as well. But again, you don't need to memorize all these. And the thing is that if you're programming or anything, you can also always rely on what the objects are actually telling you too. If you see here, if you're confused by what contains does, what you could do is hover with your cursor or use your arrow keys to get to the method name. And then you can see your contains returns true if and only if this string contains a specified sequence of car values. So essentially here, I could say, hey, does my string contain an S car? And if I can also check if my string contains a P card. So if you could see here, I could go ahead and print both of these out. Sorry about that. Oops. Let's just do this here. And great, we can see here that we have an S in our string, so we get a true, and then we get a P as well, so it's false. Now, another thing to note is that we can also use indexing in strings. You might be tempted to do something along the lines of this, because I did say earlier that a string is an array of characters. So if you do like string of 0, like so, you'll notice that it actually gives us a little error. It says the type of the expression must be an array type, but it resolved a string. So even though string is technically an array of characters, we can't really access it like an array we would usually like we would usually with an array. So the way that you can get an index value there is to use the car add values there, such as 0, 1, or 2, and then go ahead and try to access them that way. So again, you can't necessarily rely on the array accesses like normal. But you can see here, if I have a 5, I have the S. If I have an 8, I have the I, and it's the same thing. So again, if we start counting from 0, we'll go up. And now let's just see 0, 1, 2, 3, 4. If this guy is 4, let's see what we get at 4. So you'll notice that we don't get anything, but it's actually, there is a value there. If you can see, or if I click on it, it put me out one. It took into space. So the space is also a character. Cool. So what we could also try to do here is obtaining characters as input, and that's a really neat way to go ahead and try to build out a string. So what we could do here is, excuse me, we can take a look at the character class a bit more, and then look at the string demo.java file. So the character class as well is very similar to the string class with its methods, but you'll notice here that each value, or excuse me, a character class is a different way of a different way of accessing the strings. So we can actually, before we look at the demo file, you can type out char, which is car, and then you could say, let's just call this variable test, and what it's going to be equal to is the character A. And you'll notice here that the A, if I go ahead and do it this way, see if this works, you'll notice that I get this underlined red. And it says change type of test to string. So in Java, when you have double quotes like this, that means that it's going to make it into a string object. If you have individual quotes like this, that means that it is a character object. And again, these are things that you'll learn as you're just fiddling around with the code, but they're useful to get familiarized with. So just like the string, if I do test dot, let's try to see if I can say is digit. See if this one worked for me. Oh, that is telling me that it's the primitive type. Let's go ahead and jump over to the, excuse me, the string demo file really quick, and let's just see if this one's working. Oh, there it is. That's why. I forgot that it's a primitive one. Let's try declaring it like this. Okay, so character test java.lang.character. There we go. Sorry about that. So the char is the primitive one, char. The one that we want to use is character with a capital test. And then let's go ahead, or excuse me, capital C. And if I go ahead and I type in test dot, you'll notice now that I get the access to all these values here. So I can print out, let me do a print statement here. System.out.print line, and then I'll say test.isDigit. Let's see if this will work. And this might need to take in a value. Add argument to match. Test.isDigit of test. Let's go ahead and run this guy. And we'll see that we get false for this one. And if I go ahead and I make a new character underneath this one, let me make this test2, and I'll set it equal to the digit 1. And you'll notice here, this isn't an integer because I surrounded it with the 2 quotes there. Let me do test2 right here. We get a true. And now, of course, you can keep going with these ideas here. System.out.print line test.isLetter test. And we can see that these are true. So you can really go ahead and you can try to manipulate programs and put in input very easily using these processes. And you'll notice that just like we did with the string class, if you press test and dot, you will have access to all of these different commands that are there. So again, play around a bit with these. They're really cool to check out, and you can make some interesting programs. And let's take a look at the string demo file. So if we actually read this out here, you'll notice here we get our friend the scanner at the very start, and then we can say enter a string for testing. So if I go ahead and I hit play here, we could try to enter a string for testing. And then we, after we go ahead and take in this sample string, we're going to create 2 different characters, 2 different character values, which is option and answer. And then we get it equal to our y up there. So if someone puts in a y, it will go ahead and go through it. And let me go ahead and hit play here. So I'll say this is a test with exclamation point. And then we can enter a string to be tested. We do test. Which operation? E is equal to equals, S is equal to starts with, D is equal to ends with. Let's go ahead and try to equal. This is a test equals test, and then that is false. So essentially what happens here is you put in 2 different strings, and then we go ahead and we take in an E, S, or D, and then we can see down here that this is not true to be continued. So if we go ahead and hit Y, I'm going to try to enter another string to be tested. And let me actually make this a bit more easier to see. This is the first string, and then this is the second string, like so. And then let's go ahead and hit S. This is the first string, starts with, this is the second string, and then we have false there. And the starts with command is going to go ahead and ask us if, let's just go ahead and try to find it in our lecture notes here. Starts with right here. It returns true if the string begins with the prefix starting at the specified offset and false otherwise. Little typo there. But again, there's a lot of different options you could do. Starts with and ends with essentially tells you, does this start with the string that's specified there and so forth. Let me try to see if I can do this again. This is the first string. I'm going to do this. Let's do starts with, and you can see here that this is the first string starts with this, and that is true because that is telling us that they are true there. And you can see this programmed out down here. We have our if and our else ifs going on here, and you can see here that each of them are using these commands of starts with and so forth. Now, if you want to go ahead and this program is really nice to use because it goes ahead and shows how to build up a string itself. And this string demo, essentially, you can manipulate the, you can manipulate what the user is entering in and then figure out what to do with it from there.